solve the system of equations graphically. So here's our two equations, our system. 2x minus y equals negative 6 and x plus 2y equals 2. And by graphically, it means we're going to graph both of these lines and then find the point that they intersect. And the point where they intersect is the solution, the x and y. That's the solution of the system. So there are a couple different ways to graph a line. I'm going to do it by converting it to slope-intercept form, like the y equals mx plus b. And I'm going to use that to kind of graph the line. So here, you see equation 1. I'm going to isolate y, subtract 2x from both sides, and then multiply everything by negative 1. I get y equals 2x plus 6. Over here for equation 2, I'm going to subtract x from both sides and then divide both sides by 2. And so I get y equals negative 1/2 x plus 1. And so these are my two lines that I want to graph. So the first line, 2x plus 6, I'm given that it has a y-intercept of 6, so I'm going to plot that point. And because it has a slope of 2, it means for every, if x increases by 1, y is going to increase by 2. Similarly, if x decreases by 1, y is going to decrease by 2. That's what the slope means. And so I can plot points by just decreasing by 1, y decreases by 2, and you see I draw a couple points and I form the line. For this line, I'm going to have a similar idea. The y-intercept is at 1, so that's my first starting off point. And then we're going to, because the slope is negative 1/2, if x increases by 1, y is going to increase by negative 1/2. And the other way around, if x decreases by 1, y is going to increase by negative 1/2. And you can see if I go one more point here, it actually intersects with the other graph. And so that is the solution to our system, x being negative 2 and y being 2. And you can actually verify this by plugging this in for x and y, and it should satisfy both equations. Both sides of both equations should be equal.